This is Jeff Jarmock.
Hi, I'm currently a lead application security engineer at Salesforce. I was with NCC Group until about a month ago, so that's a recent change for me. But I do a lot of Rails work. I've done some Metasploit modules related to Rails and a couple other things with Brakeman and whatnot.
Yeah, and he used to work with me in the Chicago office, so that's why we've got that flag up there. So just a brief outline about what we're going to talk about today. I'm going to go into an introduction into Rails, just kind of the important parts that you'll need to know for this talk. I'm going to pass it over to Jeff. He'll talk about authentication, and then back to me for authorization and a new tool called Boilerman that we released. So jumping straight into it, this is the command that you run when you want to build a new Rails app. So you say Rails new sample app, and then this is the directory structure that starts to get built. So the first three folders we see here are the models, the views, and the controllers. So the models are kind of the ORM layer that ties objects to database rows. We've got the views. This is the ERB, usually templating engine. So this is going to be what the client actually sees and renders in front of them. The controllers are that's kind of the glue that glues the models and the views together. So the controllers just gather up the data and gets it ready for the presentation layer. In the configuration directory, you have a file called routes.rb. So this is the file that pretty much defines all of the public-facing routes in your application. We're going to go into this a little bit later to kind of see what the structure of that file looks like. And then we have two files called gemfile and gemfile.lock. So gemfile is pretty much, here are all the list of external dependencies. In Ruby, they're called gems. And gemfile.lock is when you run bundle install, it installs all of your gems. Those are going to be it's going to contain the version numbers of all the gems that were installed. So if you're looking for vulnerabilities in specific gems, you're going to want to look into that file to see what version they're running. So the Rails community has this notion of the Rails way. And this is kind of, DHH, who created Rails, calls it omakase. So it's more, he kind of puts the menu together for you and leaves little to choice. So his problem was that all of the kind of web frameworks out there were a la carte software environments. So you had to kind of pick and choose and put all these pieces together. So what he wanted to do was say, here's convention over configuration, here's what you get, and here's how we think that a web framework should look. So in Active Record, this is kind of the model layer. You're going to get a lot of things by default, like SQL protection. There's a lot of ways that can go wrong, but you kind of have to go out of your way for that to happen. So we have a link up here to railssqli.org. That's a resource we use pretty regularly to kind of make sure that when we're assessing code, these are the possible ways that it can go wrong, and these are the things that we look for. Action view is the view layer, so you're going to get things by default like HTML output encoding. So you should have XSS protection, and there are ways to kind of shoot yourself in the foot. So those are the things that we look for. And action controller is a controller layer. So when you build a new application, we'll go into this a little bit later, but you get things like cross-site request forgery protection by default via the protect from forgery method. So I think it's going to be you here.
Yeah, so this talk, though, focuses on some of the things that aren't really built into the framework, specifically authentication and authorization, and that's where we kind of go off the rails a little bit. So the first point I want to make is that authentication and authorization are two distinctly separate processes. A lot of times people lump them together and just think in terms of auth. And that mindset is oftentimes emblematic of problems down the road. It really helps in the security model to think of things as separate, with authentication focusing solely on identifying the user, and then authorization determining what privileges they have in the application. In both cases, there's not a lot of support built into Rails natively. On the authentication front, only HTTP, Basic, and Digest are natively supported out of the box. On authorization, there's really no native facility. In both of these cases, there's some helper methods and things that can help in building these that we'll talk about. So when it comes to authentication, we've got two options, essentially, of how we're going to handle that in our application. And the first is to roll our own and just write our own authentication framework. the risks here are that you're kind of reinventing the wheel, and you're likely to make a lot of mistakes that others have already made and corrected in writing authentication systems. There's a lot more to authentication than just checking and storing passwords, the obvious thing that people think about. And then in the Rails framework, there's a helper method called hasSecurePassword that's been available since version 3.1. So that's something that's built into the framework that can help us to build an authentication system securely, and we'll see a little bit more about that. The second option then is to use an off-the-shelf gem. That's one of these third-party libraries. There's some risks here as well. Vulnerabilities in gems tend to be more attractive to attackers because you can compromise a wider number of applications. So you might have a little bit more exposure. For that reason, you need to pay real close attention to ongoing updates and maintenance to incorporate fixes and improvements over time. That's really true of any library code, but certainly something as security sensitive as authentication, we want to be careful. And then of course there's still some work that you have to do to integrate it to your application and glue the logic together. And that can be a little bit tricky. But on the plus side, the core code is generally pretty well vetted and well reviewed by the community. There's a lot of people depending on the common big players in authentication. And for that reason, it tends to benefit from the community experience and improvements over time as new discoveries are made. So let's talk about some of the common authentication gems. At the top of the list here, we've got Devise. That's far and away the most popular means of doing authentication in Rails apps. It's built on a middleware layer called Warden. The next one on the list that we have here is OmniAuth. And that's primarily an OAuth gem. So when you're doing third-party authentication with Facebook or Google or something like that, OmniAuth makes that really easy. There's callbacks in Devise to support OmniAuth, so the two work together in some cases. So you can have Devise for your usual username and password authentication, but then if the user chooses to authenticate via OAuth, it'll just call back into Devise. Doorkeeper is a little bit different. That turns your application into an OAuth provider so that you can provide authentication services to other applications. We see this a lot of times with API endpoints, things like that. And then the last one that we have here, and this is not an exhaustive list, this is really just kind of the larger players, is Auth Logic. Auth Logic is not nearly as common, but it has a little bit of a unique model that makes it kind of interesting of blending sessions and authentication, whereas most times we think of authentication being implemented in the user model. On the other hand, though, there's some arguments in favor of writing gems, writing your own authentication system. What we have here is a quote from the Ruby on Rails tutorial. It's a published book as well as an online book that's freely available. That's really the way a lot of people get started in building Rails applications. The key points here are things that we hear developers say over and over again, the parts that I've bolded, that authentication requires extensive customization and modifying a third-party product is often more work than writing your own. And then off-the-shelf systems can be black boxes. I don't entirely agree with this logic. Authentication does require some customization. I think that statement is probably more true of authorization, which is going to be a little bit more tied to your business logic. Authentication tends to be pretty similar from application to application. So I don't know that there's a ton of customization, but there's certainly a little bit of work to be done. Modifying a third-party product being more work. Again, I don't really believe that that's the case if you consider all the little ancillary features that you need in an authentication system. And then the last point, that off-the-shelf systems can be black boxes. Well, that's of course true of any third-party code that you use, but that could be just as true of the Rails framework itself if you don't take the time to educate yourself and learn how it operates. So I don't think we entirely agree with this point, but these are the things people say when they want to write their own authentication system. So let's talk a little bit about how we might do that. I mentioned this hasSecurePassword helper before. And we have here an example where we have a simple user model that has a database schema with two columns, both strings, name and password digest. And we just call that helper in the model. What that gives us is some functionality like this, where we can do user new, give it a password and a password confirmation argument, and it'll go ahead and securely store that password. It does that using bcrypt, so it's a reasonably secure password storage scheme. A while back, I wrote a really long blog post with some of my thoughts on the password storage problem. But overall, I think pretty much everybody's happy with bcrypt. The other thing it gives you is some authentication methods. So you can call authenticate and pass a password. If it's not the correct password, the function just returns false. If you pass the correct password, it returns the user object. So the interesting point here is that all of this is just provided by this helper that mixes into your model. So you didn't have to write a whole lot of code, and you've got a pretty basic authentication function that's backed by bcrypt with secure password storage. The passwords are digested and stored as bcrypt digests in that password digest string, but we can just handle them as password and password confirm attributes on our model. So it's kind of nice. But what we have here is really just an authentication function. It's not really an authentication system. And there's a lot more that we need to do there. Storing credentials and having an authentication function is really just the start. There's a lot of other things that we need to think about, like how we're going to integrate that with our session management logic. Do we want to implement any sort of password complexity requirements? The third point there is a big one. What are we going to do when the user loses or forgets their password? That's something that almost every application is going to need to account for, and it's often something that we see problems with. And then lastly, you've got some other cases depending on the nature of your application. You might need the ability to log in with an API token, multi-factor, two-factor, you might need OAuth, things like that we touched on a little bit before. So let's talk a little bit about some of these points. We're not going to go into all of them just in the interest of time. But let's start with session management. So session management is just the idea of this process that identifies the user throughout their interaction with the application. So the first step is just exchanging their credentials for a cookie. That's really the initial authentication. And then in subsequent requests, identifying the user based on the value of that cookie. The third step is invalidating that session when necessary, either when the user logs out, when a timeout or some other event occurs. And then there's some options in Rails about where we store session state as it goes between requests. So we're going to talk about session state a little bit. So we have here a simple login form, username, password, sign in button. User comes to the application, enters their username, they provide their password and click the sign in button, at which point we're going to see a call like this, which is pretty similar to what we saw when we were talking about the has secure password. Just looking up the user in the database by their ID, authenticating with their password. In this case, it's correct, so the user object's returned, and the server creates a session object server side. Now this is where things differ a little bit between some of these options. In the current default, what's going to happen is that session object on the server will be serialized and signed and encrypted, and then returned to the user, and that actually makes up their session token. So on future visits to the application, later page requests, they're going to present that signed serialized session object as their session identifier. The server then will verify the signature, decrypt it, deserialize it, and recover the session state from that value. Another option is database-backed sessions. So in this case, we have a similar flow. User provides their username and password, but the server now has a database where it can actively store information. So the same deal, user's authenticated, assuming it's successful, a session object is created in the database. Now in this case, we generate a random value, and it needs to be cryptographically random so that it's not enumerable or guessable. That value is stored in the database alongside the session object. and then that's provided to the user as their cookie value. So on subsequent requests, the user provides that random value in their cookie. The server looks it up in the database and retrieves the session object from the database that's associated with that user. So there's is this me?
Yeah.
There's some pros and cons to each of these approaches, and this is just a table to summarize it. As we go through this, I've highlighted the ones that I think are a win for each type. So right off the bat, the cookie value that's provided with database sessions is random. With the cookie-based sessions, it's an encrypted serialized object. So I see that as a win for database sessions because there's less attack surface, a little less network overhead because it's a smaller value, things like that. When it comes to revoking the session, again, I see that as a win for database sessions. It's a little bit easier to enforce maximum lifetime on your sessions when it's stored in a database. You can easily enforce a limitation on the number of concurrent sessions just by ensuring that you only record a maximum of 1 per user. And then revoking it is a lot easier because you can just delete the session from your database. When you encrypt a value and give it to the user, you really can't revoke it because they now have that value. This is really the one that says it all to me. The attack surface is completely different. On database sessions, really the only option to compromise that session is to steal or enumerate that random value that we talked about. On cookie sessions, you still have that. You also have the possibility of cryptographic attacks. Session reuse can be a big problem. If I'm storing session state and I'm not validating that it's validating it appropriately, you might have things like an account balance that's stored in the session. And I might be able to make a purchase and then replay an older session token that's still valid and it shows my balance being unchanged. So that can be a problem. Long or infinite lived sessions can be more common because again, the revocation is a little harder. You can't just delete it. And then you also have the idea of encryption key exposures. If that encryption key is ever exposed to the user through a verbose error message, something along those lines, then an attacker can just create a session that identifies them as whoever they'd like to be. And the last point is to think about the overhead here. On the database side, there's a bit more overhead because on each request, I've got to do a lookup to the database to retrieve that session object. Caching can help. There's also some gems that are similar to the traditional active record sessions that back it instead with things like Redis, memcached. So those can be a little more performant as well. Cookie sessions, your overhead is basically cryptographic with the validation of signatures, the decryption process, and then the deserialization process. With the overhead here on database sessions has led the Rails team to remove support for database sessions from core Rails in recent versions. It's still available as an external gem, but their concerns about the scalability and the performance had led them to remove it. It really wasn't the default for a long time, but I'm kind of disappointed that it was actually removed from the framework entirely, because I think in the large, in the majority case, the performance issues really aren't that significant. So it's unfortunate, but you can still enable database sessions if you choose to. So the type of session you have is configured by this value in config initializer session store. So here we have it set to cookie store. The key value there, this isn't really the cryptographic key. This is the key for the key value pair in the cookie. So it's really just the name of the cookie. I've also bolded there the expire after 2 hours. That's not configured by default, regardless of session type that you choose. You have to manually configure your session expiry. So a lot of times we'll see that people don't do this and they end up with sessions that are honored infinitely. So that can be a vulnerability. If you wanted database sessions, you could change that to active record store. Again, you have to include the the active record store gem. And there's other third-party gems available as well. So on the cookie sessions, the encryption key is stored in config secrets. It's broken down by environment, so if you have production, development, staging, and so on. And then it's defined as secret key base. Now, if you have a value called secret token instead of secret key base, what you get is a serialized base 64 encoded and signed cookie. So the difference there is that it's still signed, so you can't tamper with it unless you know the key, but you can decode it and view its contents. So that could be a problem if there's ever any sensitive data stored in session objects. That's kind of a bad pattern anyhow. You usually want to just store references to objects and look them up in the database rather than storing the entire object. But we do see that arise from time to time where you'll be able to get back-end credentials, APIs to API keys to back-end systems. Things like that might be exposed through that through that value. So don't put secrets in your sessions. The next point to talk about is how that serialization process works. In the config initializer session store, the cookie serializer parameter defines how sessions are serialized. In versions of Rails 4.1 and greater, it defaults to using a JSON for serialization. Less than 4.1, you're going to get Marshall sessions. And anybody who follows Rails security is going to remember the deserialization vulnerabilities in 2013, with YAML over XML and JSON. That was due to Marshall deserialization. So Marshall, when it loads, will allow you to deserialize any arbitrary class that the application knows about. And in some cases, certain classes on deserialization will allow you to execute arbitrary code. The other setting there, hybrid, is kind of a compatibility migration setting. So when an application is configured with hybrid serialization, what happens is the server will issue JSON serialized sessions, but it will honor either JSON or Marshall serialized. So again, you've got the possibility of remote code execution if I know the key so that I can create a session object. And that's kind of interesting because you might not notice it if you're black box testing, because you're going to see JSON serialized sessions, but the application will honor it. If you have a lifetime configured on your session, you really only need to have hybrid mode configured for that lifetime, because beyond then, all of your older Marshall serialized sessions should have expired and you should never see them. But it's something to be aware of. Okay, so let's talk about lost and forgotten passwords. This is a really big one. There's a ton of different approaches to this. People like to do secret questions, your favorite color or your mother's maiden name. Those all suck. Some applications will just generate a password and email it to you, but then you have your password sitting in clear text in email. That's not good. There's all kinds of bad approaches. The approach that we like to see is a little bit more like this. Generate a cryptographically secure random token, store it in your database, associate with the user object, and store a timestamp of when it was generated. Transmit that to the user out of band somehow. Email is most common. You sometimes see SMS and things like that. The user visits the site, presents that token. In the email case, they're probably just going to click a link in their email. It says, come here to reset your password. When they do that, the application looks up the user who's associated with that token, verifies the expiration date. That's important. We don't want these tokens to be valid forever, a couple hours, maybe a day. Longer than that is potentially a problem. And then go ahead and change the password. And then the last step there, one that people often overlook, is to delete the token so that value that's sitting in their email box is no longer valid. So let's talk a little bit about devise. We're going to kind of switch gears here. Devise is really realistically the way most applications are going to deal with, with their authentication. So here we've got a simple user model that's enabled by Devise. Devise actually generated this model for us. It does that if we try to turn it on in a model that doesn't exist. And this is what you get by default. So it just loads Devise and passes all these different modules to it. So each of these modules turns on different bits of functionality on and off. Registerable, allow somebody to come in and provide their email and create an account. They all do different things. The ones that are disabled there, OmniAuth, timeout, account locking, email confirmations. Those aren't enabled by default, but it's a simple flag to turn it on. Within the routes file that Tomek mentioned, maps URLs to controllers, we really just see this one line. It just calls this Devise for helper and tells it that we want Devise on our user object. If we do rake routes, we see that one line actually gives us a whole bunch of different mappings to controllers from Devise. Now again, this is in the default and it's going to vary depending on what modules we have turned on and off. But you'll see that this gives us things like a sign-in page, a sign-out page, password change, password reset, and so on. When it comes to actually using Devise in our application, the way we do that is through some filters and helpers that are available to our controllers. So the controller filter there, it's a before action callback, so it's going to run before the controller action, and it simply authenticates the user, determines their identity, stores that as a current user. This is often put in the application controller, and Tomek will touch on the inheritance of controllers a little bit, but that way all the controllers across the application will inherit that dependency and require authentication unless it's explicitly disabled for a given controller that needs to be available anonymously. So that's a good pattern. Then within the controller, we have these helpers that can let us check on the state of our authentication. User signed in returns a true false based on whether the user signed in. Current user is really the important one because that returns the actual user object of the current user. And then user session is similar, it returns their session object. Devise has a bit of a security history. These are just going through the change logs, looking at things that are security relevant. And most of these are pretty minor. There's an unreleased commit that allows you to send password change notifications. So if my password's changed, it gives me an email that just says, hey, someone changed your password. If that wasn't you, heads up. Over the years, we've had things like disabling tokens that are outstanding for password reset when the user changes their email or password. There was an email enumeration bug a little while ago. In 3.1.0, I've got this bolded. They no longer store reset tokens as plain text. They store an HMAC of the token, which is something that's really good. If you end up with a SQL injection vulnerability or something like that where I can read the contents of the database, there's no longer a token there that will allow me to reset a user's password in plain text because it's stored as an HMAC. So that's a big improvement, and that's something that can be really easy to overlook. When we have these password reset tokens flying around, it helps to think of them as credentials because they really are. They'll give you access to the account. And so we need to secure them in similar ways that we would secure actual credentials. There was a CSRF vulnerability in, it was a token fixation vulnerability that allowed for CSRF. But then back in 2.2.3, there was a type confusion vulnerability. And this one's really interesting. And we're going to spend a couple of slides talking about this vulnerability. This was disclosed by Jorn Chen back in February of 2013. So let's talk about how this works, because it's an older vulnerability, but it's kind of indicative of the sorts of things that can easily go wrong with password reset flows. The main point with this slide is that there's been all these changes, but if you look at them, a lot of them are these really subtle things that can be really easy to overlook. And I kind of see this slide as a win for Devise, that they're improving things and addressing these little subtle flaws that that would be easy to overlook. And they're the sorts of things that people introduce in custom code all the time. So this password reset vulnerability. This is pseudocode that kind of gives you an idea of how the password reset flow in Devise works. In the paper, I go into detail tracing it through like all the various classes that are called, and it boils down to something like this. you've got a reset controller that reads the password reset token from the request, looks up the user object associated with that. If there's a user there, then it goes ahead and changes their password to the value that the user provided. So pretty straightforward, right? But there's a catch here, and it comes from MySQL. MySQL's got some really unexpected behavior with some of its equality operators. So the first one here, we've got a simple query that returns, where 1 equals 1 string. So notice that the first one is an integer, and the second is a string that begins with the number 1. When MySQL does this, it typecasts the string to an integer, does the comparison, and since 1 equals 1, it thinks that 1 equals 1 string and returns true. So that's kind of unexpected. Similarly, the integer 0 will match any string that doesn't return with an integer, or doesn't begin with an integer, and that'll return true as well. So what does this mean to Rails and to that password reset flow? Usually in Rails, the params hash is a hash of the parameters that the user provided with a request. These are usually strings, and developers sometimes think that they're always strings. So if we look at some examples, foo equals bar, fizz equals buzz, we get a key value pair with those values. If we pass integers, foo equals 1, fizz equals 2, we still get back string representations of those integers if they're just get parameters. But there's some behaviors in Rails that'll let us manipulate these types. Prior to 4.0, Rails would accept XML bodies and posts. That's no longer the case, partly because of that XML deserialization, but it can be enabled by including an XML parser gem from ActionPack. It still accepts JSON though. It'll parse those bodies automatically and typecast according to those formats. So in the XML case, if we pass fizz with a type of integer and give it a 1, you'll see that in the params hash, fizz is now the integer 1. So that'll allow us to pass integers to parameters. Similarly with JSON, we could do something like this and pass a JSON body, set up password, reset password, password confirmation, the bolded bit there, reset password token 0. So if you remember to the MySQL comparisons, if the reset password token equals 0, it's going to match a string that begins with a non-integer. So we're going to end up with a query that looks like this. In the Rails code, we're doing a lookup of a user object based on that token 0, which ultimately gives us a select where token equals integer 0. And as a result, that pseudocode that I showed earlier is going to reset the password of the first user that has an outstanding token. Now that's a little bit simplified because it's going to be the first outstanding token that doesn't begin with an integer. But generally you can think of it as the first outstanding token. So I wrote a Metasploit module for this. Again, this is back in 2013. The way this works is kind of interesting because you still can't target it since all you're providing is the token. You're not providing an account ID. So I just loop through outstanding tokens. You can monitor the response code and just keep sending reset requests and resetting passwords until you get a value back that says that there's no outstanding token that matches. Once you do that, you can request a password change for a targeted user. Oftentimes you're going to want it to be an administrative user or something like that. Once you know that user has an outstanding token, you can again loop through, try 0 first, and if that doesn't work, maybe their token begins with 1. If that doesn't work, maybe it begins with 2, and so on. And eventually you'll hit that token and reset that password. This is really effective. The only downside is that the legitimate user will get an email when you issue that password reset request that will contain a token, saying, "Oh, you tried to reset your password." But a lot of times people aren't going to be too suspicious of that. So this is patched in Devise. Again, this goes back to 2013. So there's the CVE number, the specific versions that are patched. The patch is kind of interesting because if we think back to that pseudocode where they're reading the reset token from the params hash, all they really do is just typecast it to a string. So that way they know when they're looking it up in the database, it's always a string and it's going to behave as expected. The core vulnerability here, though, with the MySQL type confusion exposed through Active Record affects a lot more than just devise. So we found almost this exact same vulnerability in first-party code where people have written their own authentication. Could also arise when you have API token logic, really any kind of token authentication. The history of the fix on Rails is kind of interesting. They rolled out a fix in 3.2.12 that would build the queries based on the type of the database column that it was looking it up on. So instead of allowing MySQL to do the typecasting, Rails would, Active Record would try to do the typecasting appropriately. It was fixed in 3.2.12. It's kind of an incomplete fix. There's still some ways to exploit that Jorn pointed out. He just wrote a paper for FRAC that talked about all kinds of Rails vulnerabilities, and this is one of them where you can pass arrays and still get integers through. The fix in 3.2.12 was actually reverted in 3.2.13 because it broke some other functionality. So 3.2 Active Record will still allow you to build queries like that. It's fixed in devise, but other applications can still perform that. On the 4 and higher branch, it's not until 4.2 that they started typecasting queries by default to hedge this. Even when that's the case, you still have things like this where rather than using an Active Record find by, the user might use a where clause. And even though it's parameterized and it's not going to be vulnerable to SQL injection, in this case I can still set the type of that token, and I can still exploit this even on a fixed version of Rails. Again, you can pass tokens as arrays and still get them typecast. So it still kind of has some life, even though it's an old vulnerability. So with that, Tomek's going to talk about authorization a bit.
Oh, nice. So. All right. So now that we've kind of authenticated the user, let's see what can they do. So when we're looking at authorization, this tends to be tied to the concept of roles. And I like to kind of split it into two groups. So you have this notion of vertical authorization. So here we have kind of a list of example roles. You might have a site admin at the very top, has full access to everything. An organization admin that might just have full access to the subset of data that belongs to that organization. A regular user that might have limited read access, local write access to their user profile, and then unauthenticated. Then you have this notion of horizontal authorization. So this is, users from organization 1 should never be able to get data from organization 2, for example. Or within an organization, one user shouldn't have access to another user's data. So what does this look like within Rails? Vertical authorization tends to be implemented through the use of what are called before actions. So this is just a notion that, here we have an example controller called the post controller. The before action just says, if we're looking at the first line here for require admin, it says run the method require admin only on the create organization action. Or if we're looking at the last one, it says require an organization user for every single action except public posts. So for horizontal authorization, this tends to get implemented through the use of associations. So through your models, you can connect models and create these associations between models. So here we have a current user. We call .organization to get the organization that they belong to, and then call .posts on that. So when this gets converted to the database query in the back end, you're only querying the subset of posts that belong to that user. All right, so jumping into controller routing, we've previously kind of talked about the routes file. So this is going to be an example route that you'll see in routes.rb. It's pretty straightforward. You're given the HTTP method, the path that a user would actually navigate to, and then what controller and action that points to. So here we have an example post controller with an index action. And then on the post model, we're calling .all, gathering all of the posts, putting it into this post variable, which is going to get used by the view to actually present it. So kind of now that we've looked at what a controller looks like, let's talk about the controller hierarchy here for a second. So if we're looking at this is the application controller. So when you actually generate a new Rails application, these are one of the controllers that get generated by default. And this is going to be, the application controller gets inherited by all other controllers by default, right? So if you run Rails generate controller, and you give it some parameters, it's going to inherit from application controller. And this gets some nice things by default, which is a protect from forgery here. That ultimately what that's going to do is run the verify authenticity token before every single action. So you're getting CSRF here. Here we just have an example before action that says authorize user, and so this is going to get run on every single action inside of your application by default. So if we're looking at the post controller, we're inheriting from application controller, and that itself inherits from application base, and it kind of goes up the chain. But I think the important thing to remember here is the further up you go, it starts stripping this functionality, right? So if you have some lightweight controllers that maybe inherit from application controller base, you might lose some stuff there, and we'll talk about that later. So with authorization being implemented through the use of these before actions, we're going to dive into that a little bit, because there's ultimately three types of callbacks. You have before, around, and after. But because you want to authorize the user before you do any actions, most of the authorization, in fact, I'd say all of it, really is going to be implemented through the use of these before filters. And so you're going to see this in a few different flavors. These are some of the most common, and as we go down this list, they get less common. But you can give it flags to say only specific actions except, wrong button there. You can say if or unless, so you can actually give it a method to call. If that returns true or false, then the before action will get run. You can say skip before action. So in the application controller, we had that authorize user, and that's going to get run by default in every action. You would use this to say, if you have a public controller, for example, you'd say skip the authorized user action. You can also give it procs, which are just like blocks of code that can get run. You're not going to see this very often, though. So like devise, there are a few authorization gems that are available for Rails. And pundit and can, formerly can, are the two probably most famous authorization gems. So pundit, when you kind of look at it, both pundit and can try to centralize all of the authorization roles in a single place. So for can, that's in the abilities file. For pundit, it's through policy files. But ultimately, you're still going to kind of get the same thing. Within your controller actions, here you'll see that we're calling like the authorized user. And so that'll take the current user that's logged in, make sure that they're authorized, and if not, it'll throw an exception, and the controller action won't complete. So there's kind of an interesting thing here where in the pundit documentation it says after action verify authorized. And this is kind of the reason we touched on it a little bit before, but you don't want to put any authorization code in after actions because this is going to get run after the controller action occurs. So if you have any state changing creates or destroys, that's going to get run, that's going to change the database, and then an exception is going to get thrown, which is kind of useless in the sense of actual authorization. Pundit, this is meant to just be used for the developer to say like, hey, this is going to throw an exception, you should look at this and call authorize. So can is very similar. Based off of the abilities file, you can call authorize. It does the same thing where it looks for a current user object, takes that user and sees if they can, say, read a post, for example. So let's talk about things to be on the lookout for. So the first one is going to be calling find by methods directly on the model. So here we have an example. We're saying let's take posts, find by author, and pass it an email. So this is going to actually query the entire subset of posts in the application, or portfolios or accounts. And so with that, an attacker can just provide any arbitrary ID or email and get data that they potentially aren't supposed to access. So we like seeing associations that we touched on before. This is going to query only the subset of data that belongs to the currently authenticated user. So whitelisting when using before actions. So this is they're gonna. So in this array, you're saying for the update, destroy, and create methods, call the authorized user method. But then you have a developer that might come in, add a new action to the post controller, and they forget to add their action to this array. And so that's going to create an authorization flaw. We prefer to use the use of the kind of except. So this is going to say, by default, run it on every single action in the post controller, except for this method. And so if we go back to that scenario, a developer adds a new controller action, it's going to throw an error by default. So it's going to force them to look into this before action and see whether or not they actually need to run it. So lightweight controllers, here we have two examples. We've seen before action controller base and action controller metal. Well, metal we haven't actually seen before, but action controller base is pretty common. And so what's going to happen there is if you have a controller that skips the application controller and just inherits directly from action controller base, which doesn't have CSRF protection or doesn't have all of the authorization filters that you want to run by default, then you're going to have quite not only CSRF, but potentially some authorization authentication bypasses here. So if you see it inheriting standard from application controller, you should be in a relatively good position. Authorization logic in views. So in the views, they're correctly checking whether or not someone's an admin, and they're going to hide and show functionality. But on the back end, there's nothing stopping an attacker from just making that request directly to the server, and the controller is going to process it just fine. So here you just want to ensure that the application is also verifying the permissions and roles in the controller actions that correspond to the links or the buttons in these views. Skipping of filters. This is something that it's one of the first things that I look for. Pretty much grepping for skip before action, skip before filter, and assessing why are they doing this. Like, did they actually mean to do it? Was it like kind of lazy coding? You might think of an example where a developer wants to test their application using curl, right? And so they're going to add skip before action, verify authenticity token because the CSRF token is being annoying. They forget to take it out, and then so now you have an entire controller that's vulnerable to CSRF. Rails scaffolding will actually, so Rails scaffolding lets you generate, models, views, controllers really quickly. So here we're saying Rails generates scaffold a bank account model, and then we pass it some parameters to say, what are going to be the columns in the model. So here you get nice things like the controllers, the views, and then the models. And that all gets generated, you migrate it, and you have a form that you can use really quickly. The problem comes in with these JBuilder files. So one of the things that it'll generate this JBuilder file, which if you request a .json extension, it'll return this this view. But what'll happen is that every single parameter that you pass into the scaffold command will get added to this. And these are files that developers sometimes don't really look into or don't really use. And so if you have any sensitive attributes on your model, this is going to get added, and those are going to be available. So that's something to look into. It also will add all those parameters to the permit method for mass assignment. So automatically, all of your attributes on the model that you specified are going to be mass assignable. So looking at Boilerman, so before Boilerman, you'd have to audit every single controller manually. Not only every controller, but you'd have to track the inheritance. If there's a base controller, if there's an API controller, you have to go into that, and then kind of think about where is this potentially going to get run. So Boilerman tries to help with that by dynamically resolving callbacks through the inheritance chain, and ultimately what it's doing is it's giving you a nice list of all of the controllers and actions in the Rails application, and giving you a list of all the filters that are being run. So a bit on how it works. It's a dynamic analysis tool, so it has to plug into an existing Rails application. And it runs as an engine. So at the very least, you need Rails console access. Sometimes this isn't possible with assessments, but if you're on a kickoff call or something, I would highly recommend getting Rails console access, because even outside of this tool, it's extremely powerful. It pretty much gives you a scripting interface for the entire application. And that's kind of the concept that I use to make this tool. So I'm going to go into a demo here really quick. So here I'm using RailsGoat, which is an intentionally vulnerable Rails app by Auth. It's a complete full application. And so here I've got Boilerman already installed. So once you actually have the gem install and run the generator, you can just go to /Boilerman. And here's going to be the view that you're going to see. So you're going to have a filter list at the top. And then here's the thing that's going to be the main kind of meat of the tool here. This is all of the controllers in the application. And then you have the column for every single action and every filter that's being run. So I don't know if anybody here has experience assessing Rails apps, but if we're looking at the filters on some of these controllers, there should be something that you might be noticing not being run on every single action that should be. That's going to be apparent here. That's going to be the verify authenticity token. So if we kind of look into the application controller of the application, at the top here, what you would expect, they've commented out the protect from forgery with some note about C surfing. But here, in terms of so if we start looking at some of these filters, you start noticing the use of this authenticated filter. So I might add this to the list to say, show me all of the controllers that aren't running authenticated, for example. So now this is going to pop up here. And we're seeing some things that you might expect, the new and create actions for users. So these usually aren't going to actually require authentication because you want to either create a new session or create a new user. But if we start looking down here, we start seeing that the API do not call authenticated. And if we go through this list here, we do see that they are calling valid API tokens. So there's a different authentication scheme being run here. So if I'm looking at the APIs, I might say, show me all of the API controllers. Now show me all the ones that don't run a valid API token. So here we start to see that the mobile controller actually is not running this method. So if we look at some of the routes that are available for the mobile controller, which are right here, and if we look into the actual mobile controller code, we see that, okay, we have a before filter here. We're skipping authenticated because it's an API, but we're not seeing any call to valid API token. So theoretically, we should be able to access all these actions without authentication. So if we go to the index action, for example. So we're getting a null object where we would normally expect an HTTP authorization. If we look into the index action, we're saying it takes a parameter of class, turns it into a class, constantizes it, and then calls .all and renders it as to JSON. So we should be able to just say class equals user. And here we're in an unauthenticated session. Okay. Well, I think I may not have run the actual migrations.
Oh, you didn't get the database.
All.json. There we go. So here it just returns all the users in the database with auth tokens. So yeah, when it comes down to it, if you've assessed Rails applications before and kind of see that list of all of the controller and action breakdowns, it's a really nice tool to have, and it makes assessing authorization in Rails just so much quicker. So yeah, that's pretty much all of it. Just run gem install Boilerman, put it into the gem file. Again, the takeaways, Rails console is super powerful. Always ask for it if you can during Rails assessments. If feature ideas for the app, adding some D3 visualizations, source querying. So when we looked at Pundit and CanCan, just being able to say, give me all of the controller actions that don't call authorize. So that should be coming up pretty soon, hopefully.
You want to show the console interface?
I just don't think we have time.
Okay.
Yeah.
Yeah, where are we at? We got. Okay. Questions?
Yeah, questions? Yeah.
For clarity, because you said Boilerman is dynamic analysis tool. From what it looked like, it looked to me as a static code and analyze.
Yeah, so so for Brakeman, for example, that's a static analysis tool that actually runs over the code and does static analysis over it. Boilerman in the background is actually querying the application as it's running. So it's actually running as if you were running Rails console. And dynamically, as the app's running, checking what filters are being run on the controller actions. So in that sense, it's dynamic. Yeah. Anyone else?
And maybe one more comment.
Sure.
Jeff, if I may.
Sure.
You mentioned it in the presentation that for the approach with using a cookie for keeping the session state, you did not really favor. That's what I thought.
Yeah, from a security standpoint, like there's obviously performance benefits, and you don't have to keep state on the server. It scales better across larger clusters and things like that. But from a security standpoint, yeah, I definitely favor having sessions persist at server side.
But as you said it, but what you want with the cookie, when if you do it, you want to have it signed.
Well, yeah, and they're signed.
You said encrypted cookie, and later on you said, well, better not put the sensitive.
Well, so there's two different.
You would want the cookie to be forgeable, right? So you want to have it signed.
Right. Yeah, and that's a good point. Maybe I wasn't clear enough. There's two options depending on which version of Rails and how you define your key, whether it's that secret key base or what's the other one? I don't even remember the exact name. But yeah, so on the one option, you get just plain text serialized base64 encoded signed. So you still can't tamper with it, but you can view it. Whereas in more recent Rails, it is encrypted. And I'm not aware of any vulnerabilities in the encryption, but it's still kind of I think it's still best practice not to put sensitive information in that session. Also, from things like the ability to replay session tokens and things like that, it's going to make it less likely that those issues are going to arise if you kind of minimize what you're storing in your session state. So for like the user identity, you maybe want to have their ID, and then you can look up their ID later on, versus having their whole actual object so it's not as big a concern on encrypted cookies because it's not as likely to be exposed, but it just kind of enforces good practices for other reasons to keep your sessions pretty thin.
It's really, let's say, if you see all the glitches that can happen when you try to implement this securely, it's really maybe the best recommendation for something out there.
That's really one of the takeaways. It's like there's a lot of little subtleties that can be hard to get right. And so, if you're using more popular code, you're probably going to be better off than most cases where you write things yourself, unless you put a lot of time and thought into it. So, with that, we're out of time. If anybody has any other questions, we'll be around. We'll be happy to chat. So, thanks a lot, everyone, for coming, especially so early in the morning.
Yeah, thank you.
Appreciate it.